All right. Hi and welcome everybody to this webinar. We're going to talk today about C6, sovereign DBaaS for an open source databases. It's running on Kubernetes and supporting a number of database clouds here, and so we will a number of clouds infrastructures as we will see. So I'm going to go through here today and give you first an introduction, then talk a little bit about the architecture of CCX, integration options, and then day-to-day operations, and then also what are next steps here. So with all that, then I also want to say that if you have questions, please take them in the chat window, and I will address them after the presentation here. All right. Just to start off a little bit here with some couple of business problems. So you might be perhaps, if you're a CSP, there are, an increasing pressure from existing hyperscalers. As you know, AWS, Google, Azure are super popular, right? And if you are on a CSP, right, then one of these foundational services that you as a CSP need to be offered to your customers is a DBaaS, right? That's just, one thing that must be there, right, to be competitive. And also then in this landscape of CSPs, often, developing your own in-house database as a service, that's going to take a lot of time, right? And I can assure you that it is not free from complications. And yeah, it's easy to do some parts of it, as we will see, but then, the day-to-day operations are a bit tougher, right? Then you might have other things here as well. And I think in both cases, in this case here, where, you're not necessarily a CSP, but you might be from some other organization where data sovereignty and for various reasons, compliance and regulations are important, then you perhaps are not able to use, one of these existing hyperscalers or and services from them, right? And in this case, you can then use CCX for your own DBaaS then internally, right? And we will see here also that CCX automates a lot of the procedures that are the time-consuming ones, right? So with that, we'll go over then to talk a bit about CCX as the solution for this, right? So we are, CCX is a database as a service, and the control plane, we're running it inside Kubernetes. So it's a 100% Kubernetes native solution. The data plane is running then on virtual machines, right? And then it has support for quite a few databases. We support MySQL, MariaDB, Postgres, and Cache22, which was, Redis, and then SQL Server support as well. For Postgres, we're also then supporting various plugins, for example, Vector, right? The data plane supports, we support a number of the infrastructures on the data plane side. And well, in this webinar, we'll be talking mostly about OpenStack, CloudStack, and KubeVirt. But we also have support for AWS and Google Cloud, right? And all of these ones can run in tandem at the same time inside a CCX installation, right? So you don't need to pick and choose just one. You can actually have all of them, right? Also here, if your cloud setup or if your infrastructure supports multiple availability zones, well, then you can benefit from that as well here. And then, of course, also multi-region support, right? With that said, I want to show you the picture of the CCX control plane here. And to the left here, as I said, you see the control plane here, and on the right side, we have the data plane, right? So the control plane, this is what you install on a Kubernetes cluster. And the CCX control plane consists of a number of backend services. I'll talk more about them. And we have some metadata repositories and then also some auxiliary services, right? To the control plane then, for the end user then, we are also having, a front end, a web front end. We also have an API so that your end users can consume the service from, programmatically as well, right? And then also a Terraform provider, right? So that it is possible to create resources on your data plane using Terraform. Right? And then also, different an admin panel as well, right? So that you can see what happens and you have a quite detailed control over and graphs showing, the status of the systems and of the pods that are deployed in the control plane, right? So so what you need to do here is that you need to put aside, you need to provide the actual Kubernetes cluster. So you need to have that part running, and then you can install the CCX control plane on that Kubernetes cluster. You would then configure up the services here, right, to point to the infrastructure that you have, the data plane. So in the data plane, that is where the end users, your customers or your organization will deploy its data stores. And the data store, it's one or more database nodes that are running, right? And if you have, for example, MySQL, the data store can be, a MySQL replication. It could also be a multi-primary solution, for example, right? So for these different types of databases, we're supporting different topologies also inside the data store here. Okay. And then you can, as I said earlier here, deploy on a number of different infrastructures, right? So OpenStack and then CloudStack. And then also what we have just quite recently released here is KubeVirt, which is actually in a beta version right now. But then KubeVirt is like a VM interface on Kubernetes, right? So KubeVirt lets you create like VMs that you could SSH into, but they are running on or inside Kubernetes, right? But they will, behave and look like a normal VM that you would create on, for example, AWS or OpenStack or whatever. So if you have an OpenStack installation already, or CloudStack, for example, or that you have an AWS account that you would like to configure up, well, then you deploy CCX and then you configure the backend services then as a point to these cloud infrastructures. And then your customer or your end user is the one that is, wants to have, the database, to consume the database. He will go into, for example, the web interface and then do what is called a deployment there, right? And when he wants to deploy a data store, well, a request is sent to the backend services here. And we have backend services that are taking care of, well, the deployment. And during the deployment phase, the infrastructure will be created here inside the data plane. And then we are sending it to a controller that will eventually set up the database communication and set up the databases so that they are working and communicating with each other. And then we have other services that is taking care of, for example, backups. And then we have services that take care of, firewalling and query monitoring and things like that, right? There is some metadata that is needed to be stored, and the backend services here that are running inside Kubernetes, they store metadata about inside what's called a C6DB. And then we have some other another database repository called Severalnines, which is storing metadata information about, more detailed metadata information, I should say, about the actual data stores that have been deployed. Moreover, I also want to say here that we are setting up, of course, monitoring as well here. So when you have deployed a data store here, then it's being deployed with a number of Prometheus exporters. So we're using either, Prometheus or Victoria Metrics. It's you can choose either order. But one of them, and then we have exporters then that are feeding in, being scraped by Victoria Metrics or Prometheus. And then also we are forwarding logs from the database nodes to Loki, which is a log management tool. It can also be forwarded to Elasticsearch, and that the end user later on can look at, right? Right. I am then, of course, then backups is something that is mega important, right? Backups are stored on an S3 compatible storage that you need to provide. I mean, you could, if you don't have an S3 compatible storage, you could use, Amazon S3 or something like that, right? But it needs to be stored on an S3 compatible storage, right? So that's where backups end up. Another thing here is, of course, that the data is encrypted at rest. And the data in transit is also encrypted, right, in TLS. So that's a little bit about the initial architecture here of CCX. And I think the important here is, understand just now that the control plane this is what you install, and this is something that your end users will, they will access the control plane using the web interface, right, to deploy and manage the data stores. And the data plane is, where the end users, data stores and resources will be created. Right. I will move to the next slide, and it's just a little bit summary of the stack. We have, for observability, as I said, Victoria Metrics, and then, Loki, FluentBit, Grafana. FluentBit is for the log collection of database nodes. We're using external DNS to provide, nice, so to say, host names of the database nodes and easy access for the applications. And for RBAC, we're using Keycloak, right? Then for the database parts, we are Postgres we're using the Zalando Patron operator, and this is on the control plane, right? On the CCX DB and the CMO DB, and then we are using a MySQL InnoDB cluster operator for MySQL. So that's a little bit recap on the stack here. Control plane and scalability. Well, it's important that the control plane can scale, right? And we're supporting multiple replicas and scalable storage on the backend services, and then on the controller side, which is I can go back here actually and say that there is one piece here called the controller, which is fundamental for handling the orchestration here of the database of the data storage. So if there is a failure, or if there is and to take care of state handling, this controller is used, right? So it is responsible for making sure that, for example, if you want to have MySQL replication between the database nodes, the controller is responsible for making sure that the replication works, right, and sets it up, right? And if there is a need for a failover, for example, the controller is then also instrumental in that, so to make sure that the failover happens. And it's also involved in backups and some other operations as well, right? So going back here, so that's the controller here then, which is actually running as a single replica, and if that one would fail, then Kubernetes will just restart it again, right? And it has its states in this CMON-DB, right? So it will be able to recoup from that restart then in that case. So Kubernetes here then is very important then for orchestrating all of these for these services that are running here inside CCX. Right. So let's explain a little bit more how it works, right? So pretend that you want to make a deployment of a data store. The first thing that, you know, the first request that will go then from the control plane to the data plane, if it is OpenStack or CloudStack or KubeVirt, it doesn't really matter. It's the kind of the same principle. The number one thing is to create the infrastructure, and we're allocating then up the resources that the end user has specified. And you are actually, you know, as operators of the CCX, you are able to configure what kind of, you know, sizes of databases and so on, and database versions even that you want to offer to your end user, right? But pretend here now that we are creating two servers, you know, one with 256 GB and then, yeah, two with the same specs actually. The volumes then will be allocated as well, and networking will be created as well. The volumes are then, as I said, encrypted at rest, and we're using LUKS for that part then. So when the infrastructure has been created in the data plane, the next thing is that from the control plane, we'll call what is called a create cluster job on using this controller that is part of the control plane that will then set up the replication links between the infrastructure that we created, right? So when we're creating the infrastructure, we're also running Cloud Init, and we're relying on Cloud Init then to make sure that the host in question is set up adequately with, you know, SSH keys and also that the software is actually, you know, installed and so on, right? The database software and all other software that is needed, make sure that this is present on the host. So then it's for the controller then to make sure that the replication links are set up. The next step it will do is also make sure that, you know, backup schedules are created on the nodes here so that we are can have backups, and also set up observability, right? So that we get monitoring and can forward information to the UI and show database charts, for example, and performance charts and things like this. And after this then, right, now we only have, I should say here, the primary, we have a primary and a replica, right? And we have here, you know, just the IP addresses, right? But we can't really just give the IP address to the end user, right? Because in a cloud environment, one thing that often changes is the IP address. So it's not stable, right? So that's why we use external DNS then to map the IP addresses to some FQDNs that are immutable, right? So in this case, for example, we have the data store example.com. That FQDN is pointing to the primary, and then we have a replica FQDN pointing to the replica, right? And this is set up using external DNS. So external DNS, we picked that because it offers kind of an interface to a number of DNS providers, right? Because CSX is something that you can install yourself, but we don't know exactly what DNS you have, right? And we can't implement support for all the different DNS options there are, right? But luckily there is this external DNS in Kubernetes, and in there you can basically plug in the DNS that you have. So if you don't have a DNS, for example, you could just you can actually configure to use for example Route 53 or Cloudflare DNS service, right? So that you can benefit from this nice FQDNs, right? Because as an application programmer, then they will, the application would connect on datastore.example.com, then it will always hit the primary, right? And if the primary fails and some other node is selected as the primary, then the datastore example.com will still point to the primary, regardless if the IP addresses here would change, right? So that's external DNS, and of course then between the end user application and the data plane, well, we're encrypting it using TLS, right? Another thing that is mega important in in a DBaaS is to handle state, right? Must always know what is the correct state of the database node, of course, and so that we can determine the state of the entire data store, right? Because it's very easy to deploy something, right? And it's very, everyone can pretty much run, add into Cloud Init or write some setup script to set up, database nodes, set up replication, so it's working between the nodes, right? But then you need to maintain the state of it, right? And for that, we're using this controller from the control plane, which is continuously monitoring the database nodes inside the data store, and then feeding the state into a control loop, right? So the control loop will then react on this state, right? So if the data node is started, well, everything is good, right? If the data store is failed, then obviously something needs to be done, right? And I will come back to that in a little while here. Just to take a little step in another direction here now. If you want to try this out, well, it's pretty easy to get up to the point that we have got right now, right? Up to this point, we have been, we have set up the control plane. We have configured our cloud credentials, right? And to point to the appropriate cloud, and then we have also configured different offerings here in terms of flavors and volumes, what we want to show to the end user, right? And the thing here is that this is pretty straightforward, and at this point now, when we have done one, two, three, well, you have been able to create a data store, and it's up and running. You can then choose different options here to integrate it. We have you can do an API integration, and API integration is that you would just you have a Swagger API, and you can call create a data store. You can perform different API operations using the API on the data store, right, on C6. And then another option is to white label the front end that CCX comes with, and you can customize it as you would like then, pretty much, right, with logos and color schemes and CSS, right? And then you can also just consume the web UI as it is. And I think it's actually time. I will show you briefly, really quick here, what the web interface is looking like. So I will stop sharing here, and I will share another screen here. So I hope you can see my screen here. So here I have logged into CCX. This is the main dashboard that I will see. We have a number of, or I have 2 data stores that are running here. One Postgres, 2 nodes, and one MariaDB 11.4 with 2 nodes, right? I can then, if I would like to create a new data store, I can click on the Create Data Store button, and I can choose one of these databases that I want to provide, configure, right? And then I choose MariaDB, I choose 11.4, I give it a name, say test DB, and I can, choose the configuration here. I want to have a primary replica, just normal vanilla asynchronous replication. Or I could choose, a multi-primary replication using a Galera technology. But I pick the primary replica here right now. There is also an advanced setting here if you want to tag it, or if you want to specify, for example, a parameter group that you would like to assign it. And a parameter group is just a preset number of parameters that you can assign to the database node. You can also set up from this wizard a number of email, notifications by email, so that you can add in, so you would get email notifications in certain, for certain events, right, that take place inside. That happens to your data store. The next step is that I can provide, choose the cloud service provider. And here we have a couple of ones, right? So AWS, what that is. We have KubeVirt here. We have VMware support. And then Elastic is an OpenStack database as a service, a CSP. And then SafeSpring is also an OpenStack CSP. And Google Cloud, and then Plura finally, right? So I can go in here and I can choose, for example, if I want to deploy on, I pick something here, just this, and then I pick, what kind of instance size I want to have. I can choose the volumes, and I should say that the thing here is that this UI here, the content here, you are, you configure what you want to have here, right? This is, if you want, if you want to expose, if you're a company and you want to expose, I want to, give my users the availability to create resources on my internal OpenStack. I want them to be able to create resources or data stores on AWS and on Google Cloud. You can configure it up here so that you would have them as options here, right? And then if you have regions and multi-zones, and availability zones, you configure that as well. So you decide here what you want to show here. And you also configure what kind of instance sizes you want to have. This is what you do here. So you put together all this information. You also put together what kind of volume types you have. And size, you can set an upper and lower bound depending on what suits you, right? So we'll just go with something small here. And then for this case, we're supporting private networking and public networking. And then, in this case, we have also, AWS offers multi availability zones, right? So we can do put one instance in one region and another instance in another region, right? And then click finish and zone. And now then I click finish here, and then the deployment starts here. I can go in here into another data store here, and then you will see dashboards about monitoring. You can see events and logs about important things that have happened inside the database. And then there are different things here. So if you want to configure up a firewall, you have that's your end user. Then that this is your as an end user, you decide who wants to have access to your data store, right? And last but not least here, I'm not going to go into more detail here right now, but the DSN here, you have a DSN here, so you can pretty much copy paste this into your application, and then this is the DSN to the primary node, and then if you want to do on the replicas, then you can do that. And if you would have more replicas here, there would be DNS round robin here, so that the first time you would execute the query on this replica, and second time on another replica, and so on, right? But the primary is, of course, if you have a read-write transactions, right, that you need to execute, then you do it on the primary. Yeah, I can say also just quickly actually about users. We have you can have, create more admin users here. You can create databases. And then I said trusted sources from where you want to allow people to access your database. And one thing here, another thing here that it's we have is the ability to do parameter groups. So you can either you can create a new group, and you can give it some description, and then for some particular database type and vendor version, and then you can fine tune a configuration so that you can then apply that to every other data store that you are later on creating, right? So that's very useful to keep configurations in sync and consistent, right? Yeah, well, obviously, one thing that is quite fun actually to look at is scaling, right? So you can scale. You tune out right now. You slide up. Okay, we get another box. What do you want to have here? Yeah, something like this, and then press save, and the database will be scaled up to that. So then a job is sent now to the control plane, which will then execute this request and run it as a job on the control plane, create the resources, and make sure that this database node now is joining the data store. And it will join them as a replica because that's the configuration. But here then, let's go back here to the presentation here. So that was the web UI and a little bit of the features inside CCX. And you can do then multiple integrations. Either you white label the UI you saw, you use it as you saw it, it's up to you, or you write your own UI, right? Those are pretty much the options, right? So here is an example on how it can look like when you embed the UI inside, an existing, OpenStack Horizon portal. And here is an example of how it looks with the white labeling, where it's the same UI you saw before, but with a different color scheme, right? And CSS and logos. So now at this stage, as you saw, well, our database is up and running. We can create different databases Now, the hard part, right, is the lifecycle management, because anyone can create the infra and anyone can set up databases. That's, really easy part. But, the day two then, scaling. As you saw, you need to be able to scale up and down, and you need to be able to scale volumes. And here we actually didn't show that in the front end, but we have support for volume auto scaling. So that if you as the, your end user, the one that has, owns the data store, can set up, can say that I want to, if the disk is reaching 80%, then I want to auto scale the disk, right? And this is just a safety mechanism, so you won't run out of disk space. Running out of disk space in a database is not fun, right? So volume auto scaling is a great thing. But then also, you need to take care of backups and restore, then failover and automatic failure handling, database configuration management, and upgrades, right? While it's operating at scale, and there must be no human interaction here at all, right? This must be really, automatic, right? So what happens if, for example, we have a failure? So that the primary node here goes down for whatever reason. We don't know why. Do we care? No, it's just down, right? The thing here is then that, of course, the application can connect then to the primary node. What we need to do then is that we will do an DNS failover and point the primary endpoint. We will point that to the replica, which we will promote to the new primary, right? So if the primary fails, we need to promote the replica, one of the replica, the latest, of course, the latest updated replica needs to be promoted to the primary. And then in DNS, we need to reflect that change, right? That's what we have to do. Yeah, this and a failover is, can be fast and it can be slow. So depending on database configuration here, if you have, a multi-primary, failover is usually faster than if you have a primary replica setup. In a primary replica setup, you might have that some replicas are, lagging, even though the replication we use semi-synchronous replication. So we always know that the data, that when you have committed data, it will be on the replica, right? But it's not for sure that it's been applied yet on the database node. And so it might be queued up there, right? So when we do the failover, we must first wait for the replicas to apply all of its, transaction queue basically, and then it will be promoted, and then the DNS will be updated. So we don't risk any data loss, right? That's something we want to avoid. And if the data primary fails, I mean, it can be failed for any reason, or any node here can actually fail for any reason. And we don't want to go in and SSH to a node and, issue commands and try to fix things, right? No, in order to make it possible to handle this at scale and easy and, and automatic, we're relying on immutable infrastructure. What that means is that, as I said, we will not go in and SSH to a node, or no operator will go in and try to fix up. No DevOps guy will go in and SSH and try and fix up things, right? That's, we can't do that. And our software will not try to resume any replication links and fix up things like that. No, instead, if a node fails, we will simply add a new node by creating infrastructure and update the DNS and make sure it joins the data store in the correct topology as a replica or whatever it is. And then we remove the faulty node and remove the infra and just delete it from the platform. And of course, we need to balance here. So we have a constant size of the data store. If the user wants to have X number of nodes, well, the system, SysX, will always drive the system to have X working nodes, right? So if you had 2 nodes, one fails, SysX will then add a node and remove the faulty one, right? And this is a simple and very powerful mechanism, right? Because what will happen here really when the primary fails is that, we will elect a new primary here. Okay, fine. And we will add, we'll elect a new primary here, and we will add a new replica, right? And we will simply, remove the faulty node when we have added the new replica here. Okay. So that is very powerful mechanism. Right, I should also say that, I can actually show you. Let's do the summary here now. So what's important in this environment is then, of course, that you have enough logging so you can do troubleshooting. So both as you as an operator of SysX, you need to be able to have logs, right? And so short database logs are also forwarded so you can see them. There are logs from the different services and so on. So that's essential for troubleshooting, and then we have it in Loki or Elasticsearch. And also then for the end user, the one that is using the data store, is also able to do basic troubleshooting by looking at database logs. I can show you that in the UI in a little second, how that looks like actually. And it's easy to do deployment of data stores, and then the 2 operations is much more complicated. And one thing here with the day 2 operations here is around upgrades, right? And that's also something that we let the user to schedule. So we, as the operator, you set up kind of a schedule that, hey, there's a new version, right? Because upgrades needs to be handled, right? Because there might be a new database version, or it might be a new version of the Linux kernel that fixes some important CV, right? So you want your users to upgrade. So you basically, you change a timestamp inside SysX configuration, and then what will be the result is that the user will be prompted to carry out this upgrade, and the user can then choose when they want to perform this upgrade. And we are actually using this immutable infrastructure way also there. So when you do the upgrade, we are first updating we're updating one node at a time, and we do it by adding a new node, a new replica, and during the upgrade. So that replica will be installed with the new operating system, with the new database version. And then we will remove the oldest database replica, right? Then we will add a new node, and with the new version and so on, and we'll remove what is the oldest replica at that stage. At some point, we will, when we have upgraded all the replicas in this manner, it's called roll forward, then it is time to upgrade the primary. And when we upgrade the primary, then we will do this failover as well, right? A graceful failover, so that we will preempt the transactions running on this node and basically, you know, start refusing new write transactions, but and then promote one of the replicas to be the new primary, right? And one of the replicas is then of the new version. So that's how we do that. Roll forward, and it is this customer that is the end user that is responsible for when he wants to do it. Now, you can also set a deadline when this must be done. So if the user does not set anything, then you know it will be enforced, right? Yeah, backups and restore is of course important as well. Then I showed you anything around that right now, but from the I can show that in the UI next here. In the restore, you can restore a backup into a new database data store as well, right? So you can create a new data store from a backup, basically. And then want to keep it simple because the simpler procedures you have, like the immutable infrastructure, and to use that in every way, you know, whenever it's a failure or if it's about upgrades, whatever it might be, then, you know, if you want to scale up the instance actually from two CPU to 4 CPUs, well, it's the same thing. We're always using this immutable infrastructure because that's, you know, something that is working. And it's working in the same way across all the different cloud infrastructures that we support, right? So regardless if it's KubeVirt, OpenStack, CloudStack, whatever, it works the same way, right? So if you want to try it, well, you can install CCX on your laptop, and it's pretty straightforward to do that. And if you have any questions, you can let me know, right? But I can show you here. We have documentation about CCX. We have an admin guide and a user guide, which explains also the architecture and you know how to do the installation and so on in more detail. But if you quickly want to get going and try something out, we have here instructions on how to get started with actually using Docker desktop and enabling Kubernetes inside Docker desktop. This I can recommend. If you have any problems, just let me know, and we'll try to help you on this. We also explain here in documentation about, you know, day 2 operations and troubleshooting guides, and all these things is in here. Then I want to just quickly go back here. So here we were scaling. We had 2 nodes before, right? And now we have 4, another replica here right now then. And if I want now, I could promote actually this replica to become the primary one. Actually, I would like to promote this one in that case, because this is a medium size and this is a small one. So I can add a node of bigger capacity, more disk, more RAM, and more cores. And when I've done that, I can promote this one to become the new primary, right? And the same thing here is that I can show you on another system here that we nodes here that you also have the option here. You could reboot a node, for example, right? That could be useful in some cases if, it's always possible to write very nasty SQL queries, right? So that you can lock up your system, right? And even if you try to kill the transactions and so on, it's deadlocked perhaps inside the database because of a bug or whatever it might be, right? And then one way out of that is rebooting, right? Let's see if I have some backups here. No, I don't have that. Otherwise, backups would be showing up here. And then firewall. And then, yeah, one thing here is about the upgrades. So the user here is setting when they want the end users then setting when they want the upgrade to happen, right? So yeah, on say Tuesday starting time at 3 o'clock, there will be, now this is an acceptable time for starting the upgrade, or you can press, the upgrade now, and then you will carry out an upgrade in a roll forward fashion, right? And then auto scaling of storage is enabled by default, right? So yeah, that's pretty much how it is looking, and I think this promoting takes a little while here, but I think this is pretty much all I wanted to show you right now, and yeah. If you have any questions, just as I say, email me, right? And if you want to learn more, yeah, we have product documentation there, Helm charts on Artifact Hub. Yeah, but it's all in the documentation as well, right? And yeah, great to connect with you guys. So thank you very much, and by that, I think it's time to take some questions. I am not sure how we do that in the best way. Yeah, okay. I see some questions here. So this was from one question here is around how are you encrypting data at rest? And yes, that is by looks then. I don't know if that's if that answer is enough, but we're using Lux to encrypt the data. And we are generating the key inside CCX and then, yeah, encrypting using that. And here I have some question. How does external DNS update the IP address when a failover happens? Well, yes, we are basically creating a Kubernetes service that is responsible for updating the DNS. And the failover, updating the DNS, as you know, will take some time, right? So it may take a number of seconds, so it's up to TTL. So the TTL needs to be short and so that the DNS is updated quickly, right? And the clients also, yeah, comes with some baggage here, right? However, if you are a client, if you are the end user, as the end user, you don't need to connect by these FQDNs. You can connect by the actual IP address or that some other host name that we present. It depends on how you configure the system, right? If you want to present a host name or an IP address, right? So you can shoot directly, so to say, on the nodes, right? Which might be fine, right? In some circumstances, right? How is a failure detected in the primary server detected automatically? Well, it is this controller that is part of the control plane that is detecting that the server is no longer running or accessible, and then when it has determined, it's doing a number of checks to verify that the primary server is down. And then it will then, as I said, roll, check which replica is most up to date. Okay. And make sure that that also the replicas have applied all the data before the replica is promoted, right? So that to avoid data loss. Yeah, how does TLS help secure the connection between user applications and the server? Yeah, let me actually show one thing here that might explain. I need to share again. Yeah, so here, I mean, what you can do here, right now we have actually, as you know, I don't know if you saw it, but we have promoted the replica here now, so it's done with that, and we have then also, yeah, also written about that in the event log here now, so that it was initiated by the user and yeah, an audit log of the events that have happened there. But yes, regarding that one, we have, you can download the CA certificate here so that you can use that with the connection to verify that you are connecting to the correct host and the verified identity, right? And then, yeah, TLS is used there. And again, you can, I think you can actually opt out of TLS as well, if you would like that for whatever reason, right? Or for MySQL database data stores, you can actually actually require secure transport here. So you can go in here and edit the settings here so that all connections must have TLS, right? Otherwise the connection will which is enforce SSL, I think it's called in MySQL. So and if the client is then not doing it, then the client will, if the client is not then connecting using SSL or TLS, then yeah, the connection will be refused, right? Yeah, that was pretty much it. I'm not sure if that answered all your questions here. But if not, please email me and we can expand on it more. But I think this was pretty much it. And I thank you all for attending and have a great weekend, everybody. Thank you. Bye-bye.